Okay, we move on to discuss more complex questions, right? We will extend the orbit question a little bit, right? So for orbit questions, sometimes with these results that we have here, for example, we know the K is gmm over 2r already. We know total energy to be minus gmm over 2r. Okay, of course, Gp we know is minus gmm over r, right? So all these three terms we have derived somewhere here, alright, as well as here. Okay, so knowing these three terms, can we plot the graph of energy against r, where r is the distance of the satellite orbiting from the Earth center? Okay, realize that any r, right, at any value r, okay, I'm referring to the satellite orbiting at a certain radius away from the Earth. Okay, so if the satellite orbits at a distance 2r, maybe somewhere here, let's say, right, my kinetic energy will, this r will replace by 2r, okay, essentially, right? So the r is the variable in this case. Okay, so let's see if we can plot these three graphs. Okay, GPE graph is quite simple. You should be very used to this by now. Negative gmm over r, if you know, is a curve that looks like that. Okay, then we can plot total energy. Why? Because total energy is pretty similar to this. It's also negative gmm over r, but it's half of this GPE, right, because of the 2 here. Okay, so what does the half of GPE graph look like, right? So for every value r, if this will be minus 20, let's say GPE is minus 20, I should expect total energy to be minus 10, right? Just looking at these two equations in this manner, right? If this is minus 20, this must be minus 10. So every time I look at a certain distance away from the center of the Earth, let's say r, okay, if my GPE is minus 20, my total energy will be minus 10, it will be half, right? Likewise, if GPE is minus 10, then total energy is minus 5. Okay, whatever it is half. So to plot the total energy graph, I just look at GPE, right? Then I half it to get total energy, right? So I can take a point here and then take a point here, take a point here, take a point here, take a point here, take a point here. Okay, so this graph over here is roughly half the y magnitude of GPE, right? That's total energy. Why? Because of the 1 over 2 inside this equation here. Okay, if I plot total energy, I can plot Ke as well, because realize that these two equations, Ke as well as total energy, actually mirror images on the x-axis, right? So the Ke graph is drawn in this manner. Okay, mirror image of the total energy, right? With this graph, we can answer some questions from your 10-year series. Okay, 204 paper 2 question 3c, right? They ask, as the satellite orbits the Earth, it gradually loses energy because of air resistance. Alright, so state whether the total energy becomes more or less negative. Okay, it's good to draw graphs for energy questions because the graph gives you a very good sense of how energy increase and decrease. Whenever I look at energy graphs, right, for energy graphs, if I go down in the y-axis, my energy decrease. If I go up, my energy increase. It's that simple. Okay, I don't have to care whether I'm in this region or in this region, it's the same, right? So if originally I'm orbiting at a certain radius r, and then I say that this energy loses, this satellite loses energy, right? So originally I'm at this position with this total energy and this GPE and this Ke orbiting at this radius r, and I lose energy. Okay, so if I lose energy, I must move down the y-axis, right? So if I move down the y-axis, I end up maybe somewhere here. Okay, so somewhere here. Okay, I must move down the y-axis, so I must lose energy in this manner. I must move down the graph. Alright, so I must move to this position. Right, so what happens to total energy? I become more negative. Right, so total energy become more negative. The question is state whether total energy becomes more or less negative. So the answer should be more negative. Right, explain the effect on the radius of the orbit. So from the graph, you can clearly see that because my total energy become more negative, my radius of orbit shrinks. Right, I go from r to r1, where r1 is smaller than r. Okay, and how to find out the speed of the satellite as I go nearer to the Earth? Alright, I can use this equation over here to find speed of satellite. Okay, I can make v the subject. I get root gm over r, where r is the satellite's radius of orbit. Okay, so if the R drops, which we concluded already, therefore the velocity must increase. Right, so that's for this type of graph. Okay, energy against distance from center of the earth type of graph. Okay, this graph is solely for orbiting systems, right? So pay attention when you use these graphs. And yeah, that's it for this video.